Hello my dear doctors. Now I'll discuss a topic that is the Friedreich's ataxia. Friedreich's ataxia is the most common of early onset hereditary ataxias. It is an autosomal recessive trinuclear repeat expansion disorder characterized by a GAA repeat in the X25 xenon chromosome number 9 that is written the frataxin. So Friedreich's ataxia is the most common of early onset hereditary ataxia. So we write HA means hereditary ataxias. It is an autosomal recessive AR, just circle AR. Trinuclear repeat expansion disorder, we are writing TRED small s, means the TREDS. Trinucleotide repeat expansion disorders, means TRED means the TREDS. Characterized by the ZAA circle and X gene circle on chromosome number X on chromosome number 9, that is frataxin. Friedreich's ataxia is unusual amongst the trinuclear repeat disorders, not demonstrating the phenomena of anticipation. So circle, anticipation, not circle. The typical age of onset is 10 to 15 years old, that is 10 to 15, circle, young age group. Gait ataxia and kyphoscoliosis are the most common presenting feature. So circle, gait ataxia and kyphoscoliosis. So neurological features are absent ankle jacks and extensor plantars, cerebellar ataxia, optic atrophy, and spinocerebellar tract degeneration. Other features are hypertrophic obstructive cardiomyopathy, HOCM, HOCM, 90% most common cause of death. Diabetes mellitus, the 10 to 20%, and high aorist palate. So I did listen very carefully. Before going to the Friedreich's ataxia, I'd like to give a box. Friedreich's ataxia, as we already learned, is a trinuclear repeat expansion disorder and also is a part of hereditary ataxias. So if you write a small box, my dear, SS box, that is hereditary ataxias equal to, just write it down, FAT. So this box will be helpful. Yes, hereditary ataxias are, FA means Friedreich's ataxia, and AT for ataxic telangiectasia. So FAT. So they are autosomal recessive disorders, even though they are structural abnormalities. So yes, hereditary ataxias are the FAT. So hereditary ataxias are basically the spinocerebellar ataxias, means they have the core problem, that is the spinocerebellar degeneration, means the spine plus cerebellum will be affected. So this is very important, my dear. Alright, so listen very carefully. So the next box for the trinuclear repeat expansion disorder, that's TREDS. Trinuclear repeat expansion disorders are the long list of diseases. They can come up into your exam. Alright? So the mnemonics of the trinuclear repeat expansion disorder, just write it down, that is F2DH. That will be helpful. F2DH does mean, that is F2 means the F for Friedreich's ataxia. Once again F for Fragile X syndrome. And D for, once again, dystrophia myotonica. And H for Huntington's disease. I hope you understand, my dear, what I'm saying. Alright. So yes, the Friedreich's ataxia, Fragile X syndrome, and dystrophia myotonica and Huntington's disease, these are the trinucleotide repeat expansion disorder. It is said that trinuclear repeats, expansions. Another word that we will study also in the chapter of genetics means the clinical sciences. They are following the anticipation phenomena. Means trinuclear repeat expansion disorders following the anticipation. What does it anticipation means? These are genetic terms. The anticipation means three words that we need to remember. Successive generations, just say with me, plus most severe form, plus early aged presentation. These three important things all together we call, that is, anticipation. Successive generations with more severe form and early aged presentation, that is called the anticipation, genetic anticipation. The word is genetic anticipation. What does it mean? Let me give you an example. As because we have got the diseases of the Friedreich's ataxia, Friedreich syndrome, dystrophy myotonica, as well as the Huntington's disease. Let's give an example of Huntington's disease. Huntington's disease is an important cause of chorea. So Huntington's chorea. So feel that as an example of me as well, Dr. Shumanto, right? I have my father, I have my grandfather. So my grandfather has got a subtle involuntary abnormal movements in the hands that happen at the age of 80, right? But my father has got a more severe form of involuntary movements in the hands, coriform movements in the hands, and my father suffered, and that onset happened at the age of 40. And me, as a doctor, right, or maybe you're right, so example, Shumanto, right, has got more severe form of coriform involuntary movements, more severe form at the age of 20. So successive generations, more severe forms, earlier aged presentation. Successive generations, my grandfather, father and me, more severe forms, right? And earlier aged presentation means the 80, 40 and 20. This is called genetic anticipation. I hope you understood, my dear. Alright. So yes, this group of diseases, trinuclear repeat expansion disorders, follow this genetic anticipation. Yes, my dear. This group of disease following this genetic anticipation, but the single disease which is not following genetic anticipation. Means what I said, this trinuclear repeat expansion disorder traits following this genetic anticipation. Exception is the Friedreich's ataxia, which don't follow the genetic anticipation. So I like to discuss a little bit more, right? So that will be helpful. So trinuclear repeat expansion disorders means that trinuclear repeats. Sometimes these are also come in your exam. So mind that this is important. So Friedreich's ataxia, as I said, is an autosomal recessive disorder. I said it. Fragile X syndrome, this is X-linked recessive disorder. Dystrophy myotonica having the D, so this is dominant disease, means autosomal dominant. Once again, Huntington disease having the D, so you can remember the autosomal dominant disease. The simple questions can come up. Which of the following disease is an autosomal dominant with the following disease, autosomal recessive. We'll discuss more these genetic things in the clinical science chapter. But at least the disease name, immediately after listening this disease name, alright, what is that? What type of disease it is? We can remember, right? So starting with this, Friedreich's ataxia is an autosomal recessive disorder. Fragile X syndrome means the X-linked recessive disorder. Dystrophia myotonia is a dominant disease, and Huntington disease is a dominant disease. That's really important, alright. So Friedreich's ataxia, autosomal recessive, but they have the protein named the frataxin protein. X-linked dominant, X-linked recessive disease, there is the Fragile X syndrome. The name of protein is the FMR1. Fragile X syndrome means the mental retardation type 1 gene. Alright. Dystrophy myotonica, DMPK. Alright. Dystrophy myotonica, protein kinase or phosphokinase gene. And Huntington disease is an Huntington gene, alright. So frataxin gene, my dear, this is very important. N for 9, we can remember. FMR1 on X chromosome, definitely. DMPK we will discuss in the genetic chapter. And Huntington, yes, the chromosome number 4. What I am talking about, this is very important. We will discuss these one also. Repetitions will happen so that we will do it very, very well in clinical science chapter. So my dear, listen very carefully now. The Friedreich's ataxia, frataxin 9, of course 9, but we are talking about the trinucleotide repeat expansion disorder. We are talking about the trinucleotide repeat expansion disorder. What trinucleotide are repeats really? So what I am saying is Friedreich's ataxia having the A, so we can remember ZAA. Just write it down. You see the fragile, the double Z, alright? So CGG, fragile. Huntington's disease, I am saying Mr. Huntington 4 times having coronary angiogram. So we can remember. And dystrophia myotonica, the CTG, we can spontaneously get it out. We can get it by heart, no problem. But you see how this is the trinucleotide expansion disorder will be really helpful in this discussion. Say Friedreich's ataxia, R means ZAA, that is trinucleotide repeat expansions. What trinucleotides are repeats? Fragile, you see the CGG, double G, and dystrophia DMPK, CTG, spontaneously we can get it out. But just remember the Mr. Huntington, we can write the Mr. Huntington or Huntington having the 4 times CAG. So simple questions will come up in your exam. Huntington's disease having which categories of trinucleotide repeat expansions? CGG, CAG, CTG, GAA, CGG, whatever. So you know, right, Huntington disease is CAG, so we can get it by heart. So this is about the trinucleotide repeat expansion disorder. So what happened that I have given an example of Huntington disease through my family members. I said my grandfather, my father, and me as well. So what happened? CAG, these trinucleotide repetitions, as for example, in my grandfather cases, maybe these repetitions happen 100 times, and maybe my father case it happens to the 10 to the power 6 times, or maybe for my case the 10 to the power 9 or 10 or 12 times. Means the repetitions is increased in a successive generations, earlier age at presentation, and more severe forms. This is called genetic anticipation, which is followed by trinucleotide repeat expansion disorders. I hope that you got it. So My dear, listen very carefully. This is very important discussions here. We hope that we got the chromosome number, we got the gene name, we got all together what these trinary repeat expansion disorders are. So the main disease now I am talking about, that is the Friedreich's ataxia. This is very important, Friedreich's ataxia. So let's start and talk about on that. Now we can get idea what does this Friedreich's ataxia means. At least we can get an idea the box of SS box of Friedreich's ataxia. At least we can write this is autosomal recessive disease plus what we can write the frataxin gene on chromosome number 9 and trinary repeat expansion, that is ZAA, and within the bracket write it down, this is strats, and write it down minus genetic anticipation. So this is the box, the summary box of Friedreich's ataxia. So genetic box, right? The Friedreich's ataxia, I said it. There is autosomal recessive, frataxin, N for 9 chromosome number, and A for AA, that is trinary repeat expansions, and they don't follow the genetic anticipations. That is important. So this is all about the Friedreich's ataxia genetics. Now talk about the neurological problems with the Friedreich's ataxia, my dear. So this is very important. So let's do it. Friedreich's ataxia. Another box for the Friedreich's ataxia. We already talked about, right, the spastic periparesis, remember? SP, remember, with plus. We have got the syndromes like the spastic periparesis, the dorsal column sign, spastic periparesis with absent jux and extensor plantar, CM fast, remember? Yes. So yes, we can write the spastic periparesis with the dorsal column sign, we can write one syndrome. And yes, the spastic periparesis with the absent ankle jux and extensor plantars. Why? Because this spastic periparesis along with peripheral neuropathy, peripheral nerves. As already we talked about the Friedreich's ataxia. Friedreich's ataxia is nothing but the spinocerebellar ataxia. So the first syndrome that we need to remember is spastic periparesis with cerebellar syndrome. Spinocerebellar ataxia, right, my dear? What I am saying, once again, another box of SS box will be helpful. Spastic periparesis plus CS, cerebellar syndrome, already we talked. The first diagnosis should be multiple sclerosis. Second diagnosis is the Friedreich's ataxia. So yes, the Friedreich's ataxia we have writing here spastic periparesis with dorsal column signs, remember, with absent ankle jux and extensor plantar, and spastic periparesis with the cerebellar signs. So we can get an idea of the Friedreich's ataxia. But my dear, listen very carefully. We call the extra neurological features of Friedreich's ataxia which can give us the ideas rather than this is not a case of multiple sclerosis. So what I am saying, the mnemonics, once again, that will be helpful, my dear. I say that Mr. Friedrichs lives at DOHS. In our Dhaka city, right, we have a place that is the name doll, DOHS, means alright, I had an experience to stay over there. So the mnemonics actually made when I stayed there. So that's why the Friedrichs is me the Friedrich's ataxia. Friedrichs man lives at DOHS. So DOHS mnemonics will be really helpful to remember these extra neurological features. And my house also at DOHS, it was the extra house, not the prime or primary house or something like that, right? So this is DOHS. So what does this DOHS means, mind? That is important. So D stands on diabetes mellitus. O stands on, that is important, optic atrophy. H stands on HOCM, hypertrophic obstructive cardiomyopathy, and S stands on scoliosis. So these are the 4 important features that we need to remember so that we can diagnose, that is the Friedreich's ataxia. I'd like to add more so that we can get an idea. So D for diabetes, O for optic atrophy, H for HOCM, and S for sclerosis. And HOCM is the most common cause of death. That's important in a patient with Friedreich's ataxia. I'm adding also more important, H for high arched palate, and S for PES. SsAcademy, we can write the SsAcademy, that will be helpful. So S for scoliosis or kyphoscoliosis, just write it down the way I'm writing. So scoliosis, SsAcademy, SsAcademy, that will be helpful. And sometimes they have the sensory neural hearing loss for the S. So this is the another SS box for extra neurological features of Friedreich's ataxia. DOHs. I hope that, my dear, you are getting the features of the Friedreich's ataxia. Now I'll discuss a little bit from your notes. There is another disease of hereditary ataxias, that is the ataxic telangiectasias. Just follow me what is written in your notes. So ataxic telangiectasias, another name of the ataxic telangiectasia is the Lewis-Barr syndrome. Alright. So once again, this is autosomal recessive disorder. We know about it, combined immunodeficiency disorder. Features are cerebral ataxia, telangiectasia, recurrent chest infections, and 10% of developing malignancy like the lymphoma and as well as the leukemia, but also there is non-lymphoid tumors. So my dear, listen very carefully what I am saying. This is the another box of ataxic telangiectasia. So the SS box of ataxic telangiectasia. The word itself says the A for ataxia. So we can write, remember ataxia means, of course, that is cerebellar ataxia. Cerebral ataxia. And once again, T for telangiectasia. And mostly they are having the ocular telangiectasia. So just write it down within the bracket of telangiectasia. Yes. And this is very important. We will study in the chapter of clinical science of immunodeficiency. Immune deficiency, the primary and secondary can be happen. Primary immunodeficiency means primarily the causes are unknown, we don't know. So primary immunodeficiency are classified into the neutrophil disorders, then T cell disorders, and maybe the T cells, once again, the immune deficiency means immunoglobulin disorders, means immunoglobulin deficiency disorders, and sometimes, the T and B cells is a combined deficiency also. So the different categories of the diseases underlies the primary immunodeficiency. Yes. So in critical science also we will study the separate box I am writing here. That is a combined immunodeficiency. Combined immunodeficiency we will study. A box that is SCD was ataxic. So why I am saying this box? SCD means severe combined immunodeficiency. SCD means severe combined immunodeficiency, another disease, another entity. And WAS means Wiskott-Eldridge syndrome, and ataxic means ataxic telangiectasia. So why do we got in informations right? The ataxic, the word, the ataxic, cerebral ataxic, that is once again the combined immunodeficiency we need to remember. Combined immunodeficiency means there are risk of development of immunodeficiency, means there are risk of development of infections, just write it down, and malignancy, right? Infections and malignancy, just write it down. The infections, right, you see the recurrent chest infections, right, the viral and bacterial infections altogether, malignancy, lymphoid malignancy, maybe the non-lymphoid malignancy, leukemia also can be possible. So, the summary talk, right, the ataxic telangiectasia, as I said, the name of the ataxic telangiectasia is the Lewis-Barr syndrome. Alright, Lewis-Barr syndrome. So ataxic telangiectasia, you need to remember only the A and T, and we know this is autosomal recessive disorder, and A for ataxia and T for telangiectasia is enough. And just write it down that S series ataxic from these box that we are getting, there is combined immunodeficiency. Just adding this ataxic telangiectasia word, there is combined immunodeficiency. So what I'm putting, right, the AT, that will be helpful, right, the box of ataxic telangiectasia, if I say the ATC, it will be helpful. Ataxic telangiectasia, alright, once again, ATC, ataxic, T for telangiectasia, and C for, once again, yes, a combined immunodeficiency leading to infections and malignancy. Like immunodeficiency, yes, responsible for opportunistic infections and also the malignancy and HIV, we know about it, so that we can understand, right? This immunodeficiency infections and malignancy can be a possibility. So we need to remember them. So from this total discussion, it is a very, very important discussion that we have done. Starting with that, what is really the hereditary ataxias, number one, that is the fat. We need to remember. And hereditary ataxias are nothing but the spinocerebellar ataxias, means spine and cerebellum is involved. Second talk, you see the second talk, we already done having the, what is that? That is the trinucleotide repeat expansion disorders. So what is that? TRATS means the F2DH, means the diseases, and they are following the GA, that is the genetic anticipations. Alright? Next disease and the third talk, the Friedreich's ataxia, the genetics, right? And fourth talk, the Friedreich's ataxia, what are the syndrome? There is a spastic pervasive dorsal column sign, and epsilon jogs and extensor plantar peripheral nerves is involved, and spastic pervasive with the cerebellar sign because of spinocerebellar ataxia. So once again, along with these box, right, the number 5, the extra neurological features, there is the DOHs that we need to remember all together. And last talk is the number 6, that is the ataxic telangiectasia, I said the ATC. So summary, I'd like to, a bit of summary is really helpful. Summary is, starting with that is the hereditary ataxias. Hereditary ataxias is nothing but, you see the FAT, F-A-A-T. Second talk, TRATS are the F2DH. Third talk is the Friedreich's ataxia genetics. They don't follow the genetic anticipation. That is important. Along with this, Friedreich's ataxia, of course, the spinocerebellar ataxia, so spastic periphery is the cerebellar side, but next to the multiple sclerosis. Yes, along with the extra neurological features, yes, extra neurological features are, there is a Friedreich's, Mr. Friedreich's, right, the DOHs summary. And once again, the last talk, the second disease, the ataxic telangiectasia, ATC, C for combined immunodeficiency. You need to remember. So summary once again, there is a hereditary ataxia, the FAT, TRATS is the F2DH, and then Friedreich's ataxia is the not GA, And next, the Friedreich's ataxia, once again, extra neurological features, the DOHS, and last is the ataxic telangiectasia, ATC. I hope that, right, all these boxes are tremendous helpful, my dear. You'll enjoy, and thank you very much.